All right, we have problem 5 of group theory. That says, suppose that H is a subgroup of G and let D be the set of tuples which have H from H, then D is a subgroup of the Cartesian product of G cross G. Prove that D is a normal subgroup of G cross G if and only if H is contained in the center of G. All right, this is a fun proof. So we'll write a quick proof for it, and we'll do the forward direction. Yeah. LaTeX not gonna like that. I did like that. Okay, so we're doing the forward direction, which is that D is a normal subgroup of G cross G. Okay, that's what we're assuming. So assume that D is a normal subgroup of G cross G, and we want to show that H is contained in the center of G. All right, and the trick is what we're going to do is we're going to pick something in D, let H be in D, and okay, and we're going to pick something in G cross G, be in G cross G. My element is going to be G, the tuple G with the identity, G and the identity. And we'll see why this works. Yeah, and we have that D is normal in G cross G, so we could say that since D is normal, I could say normal in G cross G, we have that this guy times HH times that guy, can't type, is in D. All right, so we have this is true, and the multiplication or the operation that's going on here, it's all component wise, and that inverse just goes to like the inside. Hence we have that, when we multiply this out, we get G on the right here. Sorry, we get GHH. We get GHH when we multiply these two guys, and then we get GHG inverse H. Hence we have that, and maybe I'll just write this out. This isn't terrible to type up real quick. Quickly, we'll begin a line star, and we'll say that this is equal to, we'll do that first multiplication that I just said is this guy, and I'll do that out as well. The inverse of the identity is just the identity. And we want one more line to be last guy, which is this guy. That should be an H. Okay, so we have this guy, we multiply the first two guys and we get that, and then we put that inverse on the inside and we multiply and we get these guys. Okay, and we know that by property of normality, we have that this is in D still, and D has this special property that it's sets that look like this. Hence, thus we have that GHG inverse is equal to H. So GH is equal to HG. Hence, every element of H commutes with every element of G. Therefore, H is in the center of G. So we use this normality property and how D is constructed to get these two equal, which is just saying that, H commutes with every element in G, and so it's in the center of G. Okay, so this is the forward direction. We want to do the backwards direction. That's /implied by, keep doing that. Okay, and we're going to do a very similar trick. We're going to start off by assuming that H is, I'll just write it, set theoretically, or symbolically, I should say, H is contained in the center of G. Assume that H is contained in the center of G. I hate that it cuts off. I'm just gonna, again, stylistically just do that. Okay, and it compiles really slowly. Okay, H is in the center of G, and our goal is to show that H is normal in G cross G. So we're going to let H be in D, and sorry, show that D is a normal subgroup of G cross G. I don't know if I said H or G, but definitely D. So we pick something in D, and then we pick two arbitrary, I guess we pick one arbitrary element in G cross G. Then, kind of like above, we want to show that if I take G1, G2, and I operate it with just something arbitrary in D, and then I operate it with that same guy, but the inverse of that. That's the inverse. Our goal is to show that this is in, let me compile it for you, this is in D still. Okay, so we have this, so let's see. Hence, we have that. I'm just going to do the same thing I did before with the begin align thing. Begin align, and I'm going to take this guy, and I'm just going to do it out. So this is equal to, if we multiply the first guy with the second guy, we get G2H, just the G2 pops on the right, and the inverse comes on the inside of that tuple. Okay, and we get this guy, and so we have one more line. Oh, I thought I hit 2 characters by accident. Feels like I did. Shouldn't be a thing there. Yeah, there we go. Okay, and we do our last guy out. We get G1, H, G1, inverse, and G2, H, G2, inverse. Okay, and now we want to use what we assumed, which was that H was contained in the center of G. So since, let's see, since H is contained in the center of G, we have that, well, G1H, G1 inverse, that's just equal to H. Because, I mean, like before we had that, this above is essentially just saying that. If we have this and we have that, if it's in the center, we have this essentially equality, which is what I'm going to use to say that this guy and that guy are just equal to H. Okay, we have that, so I'm just going to take this last guy is equal to HH, which is clearly in D. Therefore, D is a normal subgroup of G cross G, which is what we were trying to prove.